Okay, in this video, I'm going to show you how to solve a system with elimination when you have to multiply both equations by a number. So if you look here, I can't multiply 2 by anything to get to 5 to get my x's to cancel out, and I can't multiply the 4 by anything to get to 10 to get my y's to cancel out. So I need to multiply both equations by something. So you can choose to get rid of your x's or your y's, it doesn't matter. So I'm going to start with my x's. I'm going to multiply this top equation by 2, so that'll give me a negative 10x. And if I multiply the bottom equation by negative 5, that will give me a positive 10x. So if I multiply this by 2, I get negative 10x minus 8y equals negative 48. If I multiply the bottom one by negative 5, I get a positive 10x and a positive 50y and a positive 90. So now I'm going to add those together, and a negative 10x and a positive 10x is 0. It cancels out. That's what we wanted. And then 50 minus 8 is 42, and 90 minus 48 is also 42. So y is equal to 1 if you divide both sides by 42. So now that I know y is equal to 1, I'm going to plug that up into one of my original equations. So I'm going to plug it into the bottom one. So I'm going to have a negative 2x minus 10 times y equals negative 18. So that is negative 2x minus 10 equals negative 18. So I'm going to add 10 to both sides. So that can give me negative 2x equals a negative 8. So x equals positive 4. So my answer is 4 and 1. And remember, we write these as an ordered pair, x, y, so it's 4, 1. Okay, let's do another example like that. And if you want to pause the video, this would be a good thing to try to do and see if you can do it on your own. Okay, so 4x minus 2y is equal to 12, and negative 10x plus 7y is equal to negative 18. Now something you can also do, some of you might be noticing this, we could divide this equation by 2 to make the number smaller. I can't do it here because I have a 7, but whenever you have an equation where everything is divisible by 3 or 2 or 5, you can go ahead and divide that and reduce it and make your number smaller if you want to. It's not necessary, so I'm not going to go ahead and do that here. So my two smallest coefficients are 2 and 7, so I'm going to work with the y's instead of the x's. It doesn't matter. I could get these both to 20x and negative 20x. I could get them to 40x and negative 40x, but I'm going to work with my y's and get them to 14. So I need to multiply the top one by 7 and the bottom one by 2. And they're already opposite signs, so I don't have to multiply by a negative. So when I multiply this by 7, that gives me 28x minus 14y equals 84. Then when I multiply this by 2, I get negative 20x plus 14y is equal to negative 36. So my y's are going to cancel. 28 minus 20 is 8, so I have 8x. And then 14 minus 6 is 8. 14 makes that a 7. 7 minus 3 is 4. So I get a positive 48. Divide both sides by 8, and I get x equals 6. So I have my first variable solved for. So I'm going to go ahead and erase this work, and I'm going to write x equals 6 up here. And I'm going to plug that now back into one of the equations. So I'm going to use the top equation. It doesn't matter which one you use. So 4 times x, so 4 times 6, minus 2y is equal to 12. And I'm going to use my original before I multiply it by 7 because I want to use smaller numbers if possible. So 4 times 6 is 24, minus 2y is equal to 12. So now this 24 is positive, so I need to subtract 24 from both sides. And that leaves a negative there, so I need to bring that down as negative 2y. And 12 minus 24 is negative 12. divide both sides by -2, and you get y equals +6. So I got x equals 6, and I got y equals 6. So that means my answer is the ordered pair 6, 6. Okay? So if you have any questions about that, go ahead and send me a comment or send me an email, and hopefully this will help you get your assignment done.